Let's examine how to have Excel calculate probabilities for the binomial distribution for us. In cell A3, you can see that I've typed, and this is just text, what the formula that we will be using is. So the formula we'll be using is the binomial dot distribution. We'll type in our value of x, n for the number of trials, p will be the probability of success, and then we will type true or false. True will mean that we want the cumulative summation of the probabilities, and false will mean we'll take the exact value. Okay, so in A5, we are looking for the probability that our random variable x is less than 15 when the number of trials is 42 and the probability of success is 35%. So we come over to the cell B5 and we want to type in our formula. So we come to the formula bar, type equals, we want the binomial, and as we are typing, the choices will pop up. We want the binomial dot dist. The number that we are looking for, the first one is our value of x. Now we want x to be less than 15 and not include it. This is a discrete distribution, so we want it to sum up through 14. Then we'll take a comma. Next, it would like to know the number of trials. The number of trials is given as 42, comma, the probability of success is 35%, which we type in as a decimal, comma, and now we tell it, do we want this to be accumulation and sum it up? Yes, we do, because x is less than 15, so it is true that we want it to be cumulative. Close the parentheses, click OK. And there, Excel calculated the probability for us. Okay, now how is that different? Let's look at A6. In this one, we're looking for the probability that x is less than or equal to 16 when the number of trials is 33 and the probability of success is 0.5. So remember, if you're not given the probability of success, we'll just say the probability of success is 0.5. All right, in B6, we type in the formula equals binomial, select binomial.distribution. This time 16 can be included, so we'll type 16. The number of trials we're given is 33. The probability of success in this case is 50%. And we want less than or equal to, so is this cumulative? This is true. Close the parentheses. Oops. There we go. Close the parentheses, and then, let's see, don't have too many parentheses in here. That's one thing. Okay, just one opening parentheses and just one closed one. Click OK, and you can see the probability of x being less than or equal to 16 when the trials are 33 is basically 50%. Okay, now let's look at A7. In this case, we're looking for the probability that a random variable is greater than 148 when the number of trials is 212 and the probability of success is 0.56 or 56%. Now in this case, our inequality is greater than, and the formula will calculate for less than values. So we have to compensate. We'll type equals, and then it's 1 minus, and then now we'll calculate the binomial distribution probabilities. This is the binomial dot distribution. We want to sum for our value, okay, 148. We don't want to include 148. This is discrete, so it's 147. The number of trials is 212. The probability of success is 0.56. And do we want this to be cumulative? This is true. I'm just going to type true. Close the parentheses, click OK. Now you can see this number has popped up with the e to the negative 0.5. Okay, so that means we would have to move the decimal point from 2.5 to the left 5 decimal places. So the probability of x being greater than 148 when n is equal to 212 with a probability of success of 56% is effectively 0.